So I want to give you a shot at understanding this conceptually. And the good thing is that the confidence interval stuff that we just worked on quite a bit is the conceptual understanding of it. In other words, if you've made sense of what we've been doing, then this is the same thing. However, it's looked at kind of from a different direction. So I want to spend a few minutes here just kind of talking about that, giving you an example. So anyway, let's do that. Hypothesis testing. And I think you would agree that's a fairly intimidating title. Doesn't that sound hard? Sounds hard to me. So let's do just quickly what we've been doing. This is an example of kind of what you would see. Let's do a confidence interval for something that we already understand. And we are at the end of this class. And I guess what I hope is that you have a sense of curiosity and maybe even healthy skepticism about things that you read. So here's a stat that I found yesterday on the internet just for this purpose. I forgot the exact numbers because I turned it into a simple answer, but the average US household has 3.3 guns. Now, that's not the stat I read. What I read was, here's how many guns are in the US. And then I read, here's how many households are in the US. And then I divided those two and got 3.3. And I was searching for this exact number. And so again, what did I do? I Google searched. Which one did I look at? The 50th option? No, looked at the very first one, right? Now, do you have, I don't know, a healthy skepticism to you? Number one, you should look at that and say, well, now that I know a little bit about how studies are done and so forth, I just kind of wonder how did they get that number? Like, what is, if there was X number of million guns in the United States, I mean, where did that come from? Is that registered guns? Is that some kind of an estimate? Was it based on a survey? Did they just go around and ask people how many guns are in your house, how many guns are in your house, and then they multiplied by the number of households, and that's where they got the number? So when I say skepticism, I don't just mean I don't believe that. It's just I kind of wonder how they ran this. And then notice this doesn't come with a, well, plus or minus error. That's what we've been studying lately. So whatever, here's the stat. It didn't come with an error. And if there was, I wonder if it'd be like 0.2 would be the error. I wonder if it'd be like 4 or something really large like that. But my question to you is, do you have a gut reaction to that number? Do you think that's high or do you think that's low? I actually would really like to hear that. Like, what's your initial thought, Tisha? Seems about right to you? Yeah. Now, of course, I have a gun nut friend that probably has 200. So, of course, this doesn't mean every single house has 3. This is an average, right? So you're saying you think it feels about right. What do you think, Angela? Say again? You about right? What do you think, Jerry? Same? You guys are all thinking this sounds about right. Alessandra? You think it might be a little high? Yeah. What about you, Simon? Right. Yeah. And of course, you guys understand the concept of standard deviation now. So, the fact that my friend has 200 or whatever he has, I don't think he even knows. He would be many standard deviations above the average, right? And he'd be probably an outlier. What do you think, Dad? You think it's high? Yeah, I don't know what I think. That's kind of hard to tell. I guess I'd have to say I probably think it's about right, but it's probably because most people that kind of think guns are awesome because they're either hunters or they're into the whole self-protection thing. They usually have 6, or 8 or something like that. People that get into it end up buying lots of them. So I'd say there's probably lots of households that have one or none, but there's a whole bunch of people that have a ton of them. And so, and of course, lots of people hunt. So, you know, your first reaction to guns is kind of either violence or self-defense, but if people get into hunting, they probably have 2 deer rifles and a shotgun or 2 because they duck hunt or whatever. And so anyway, just interesting. I would guess so, but again, that's my question is, where did they get the number of guns? Because if it is registered guns, then you kind of wonder, how easy is it to get one not registered? I mean, I have a few guns. If I sold one of them to somebody else, it would still be on record as registered because I bought it from some store here in town. But they wouldn't know someone else has it. Does that make sense? I've never sold one, so I don't even know if they're supposed to record that. Anyway, but let's go on just for the sake of something quick here. Let's make a 98% confidence interval. Now, does it make sense we don't have all the ingredients for the recipe? Do you understand which set of formulas? Think about this for the test you're about to take. Do you understand which set of formulas you should be looking at to find the error in this study? Do you also understand that we don't have I mentioned this, but one of the ingredients here, we also need the standard deviation for this, don't we? Now, we didn't gather this data ourselves, so does it make sense when I went online yesterday and found this number? You typically don't find a standard deviation associated with that if you're just kind of hunting for it. So I'm going to make one up. And interestingly, don't write this down, but it wouldn't surprise me. You might think, you know, what would it be? It wouldn't surprise me if the answer to this is like 6. Now you might think, okay, that makes sense because 3 plus 6 is 9. There's people that have 9 guns, but 3 minus 6 is -3 guns. Does that make sense? That's actually possible. Now you can't have -3 guns. But based on, like I said, friends like my gun nut friend, it wouldn't actually surprise me if this was a lot higher number than you might think. It's probably not just like 1 or something like that. Because I think there is wide variation on this, because there's some people that are kind of anti-guns, obviously, because they do lots of harm. And then there's people that are gun nuts. And so actually it wouldn't surprise me if it's kind of huge. I don't know. Actually, let's leave it large. Let's even make it a little larger. So I'm going to give you like 2 minutes. Like, you should be able to pull this off. This is an example of a test question right here. I didn't say anything about, you know, which set of formulas to use, but can you produce that confidence interval? And I actually want you to write it like this. And again, of course, we're sort of assuming this was a study, but of course the confidence interval may be best is written like that. So can you produce those 2 numbers? Punching buttons in a couple of minutes. I would say if you can't, you're on the way to being in trouble. You better start studying. You better start coming in to visit me, staying after class, that kind of a thing. Because we did practice this a ton yesterday. And by the way, there's other things missing here, so you're going to have to ask me about that.
Yeah, that's what I was asking. Don't we need the number?
Yeah, if you look at your formula sheet, doesn't it call for the sample size? It calls for N, so you need an N, don't you? Now, again, I'm making this up too, because I found this number online. So let's say you did the study and you checked with, I don't know, 172 people, and that's how you did it. You just said, how many guns are in your house? How many guns are in your house to 172 people? Again, this is a great study. If you either hate or like guns, this might be an awesome final project. Go ask people, do your own study. See if you agree or disagree with 3.3. So you did the study. And of course, what you're writing down is this person said 6, this person said 4, this person said 3. And then you add all those up and divide by 172, and that's where you get 3.3. And you stick those into Excel and you get a standard deviation of 7.2. And so anyway. Yes, that is an extremely important question. So you got two sets of formulas here, right? Which one should you be looking at? What is the, as your book would say, what is the parameter of interest? What is this person wanting to know? Really, it's this. It's focused around, what is the average number of guns in a household? That's why the person did the study. They wanted to know how many guns are in a household. So they're hunting for the population mean. They'd like to know the answer to that question. So this is a mean, not a percent. Remember on the test, even if you know what you're doing, there's a lot of opportunity to write something down wrong, type it in the calculator wrong. Make sure you take me on the journey, like show enough steps so that I can see, yeah, this person, even though they got it wrong, they understand this. And therefore, I'm not taking off very many points. Let me take one last. You want to ask me a question and then. You're not finding it. That's good. I added it after. So you have it written down. as you're kind of finishing up. Really what hypothesis testing is about is like I went on the internet and discovered at least the first answer I saw. Remember, that could be a wacko that just posted that and doesn't have any idea. I'm just kind of trusting what I saw. It's on the internet, doesn't necessarily make it right. So I see 3.3 is the average. But again, the reason I took the time to ask all of you what your opinion was of this is, what if you did kind of disagree with that, or at least not trust it? This is the backbone of how real science works, which is one person does a study on something, and it could be some social behavior thing, it could be something scientific. But in order for that to be an established fact, really that study has to be replicatable, like some other person who doesn't have a dog in the fight. Keep in mind, anybody in the academic world that does a study on something, they're not just kind of doing it randomly, they're probably trying to get the doctorate. And so they probably spent 6 years working on this whole project, and they're hoping to get a PhD as a result of it and get a teaching job or something. And that kind of sounds like it feel good, right? Like, oh, I'm a PhD, that's cool. So they have a dog in the fight. Like, they do not want their research to turn into no conclusion, or we didn't learn anything, or it's made no contribution to the world of social science or something like that. And so for that reason, there's bias in almost any study because people are pretty invested in it. So if it's something you want to establish as a fact, then somebody else should be able to redo the study, maybe less biased. And if they get the same result, then it's now it kind of feels like, yeah, this is pretty established. So when I went online, really all I found was 3.3 guns per household. As a final project, you could say, well, I don't think so. I actually think it's maybe a little higher than that, or maybe a little lower. And so you go do your own study. Now your study is going to be terrible, right? Because you're only going to ask a few people, and it's going to be people you likely know. And if you're anti-gun, then you're going to get a bunch of anti-gun answers. And if you're a gun nut, then you're going to get a bunch of gun nut answers. And you're asking in Southern Oregon, which has probably got a higher gun sort of population than maybe something on the East Coast. So your study is not going to be good. Does that make sense? But if you disagree with 3.3 and then you go do your own study, and sure enough, you get something different, that's what hypothesis testing is about. In other words, the hypothesis is there's roughly 3 guns in every household. That's a hypothesis. And then you're going to test it by going to do your own study. And the question will be, is there evidence to say that no, it isn't 3.3? Now, that could mean that study was wrong and somebody did a bad job, but it could just mean it's changed. People are freaked out about COVID, and now they're arming themselves for the zombie apocalypse. And so it's on the increase. Does that make sense? Doesn't necessarily mean somebody's wrong. And so the question will be, do you have evidence to overturn it? So if you get, if the established wisdom on the internet was 3.3 and you went and got an average of 5 because you asked 40 people of your acquaintance, the question is that enough evidence to overturn 3 and say they were either wrong or life has changed since that study was done? If you did not screw this up, you got approximately 4.6 for the top end and 2 for the bottom end here. In the interest of using your time, I don't think I'll write out all the steps that it took to get there. However, I would like to show you at least just one interesting thing. For you more algebraically inclined people, just notice what I typed in here. I typed, isn't this, like I typed the whole thing in one step. I'm not encouraging you to do that because it's confusing. And like I said, if you don't show some steps on your test and you get it wrong, that's going to be a problem. But isn't this the error? The inverse t times the modified standard deviation, that's the error. And then we're supposed to add that error to 3.3 and subtract that error from 3.3. So like I'm a math nerd, so this doesn't intimidate me to write out a big statement like this. But isn't that kind of cool? None of you are doing it this way, right? But isn't that kind of cool that you could just type the whole thing in all at once and pop out the answer? Cool. Go ahead. I don't care.
Okay.
On my test, I'm not going to fuss with rounding, and you can see why, because on your online homework, that has sometimes been a total pain, right? So notice my answer was 4.5892 and stuff. So I called it 4.6. And my artistic logic to that was, well, the original data was rounded to 1 decimal place, so I thought it made sense for me to do the same thing. Let's see, let's see my screen. Yeah, I mean, you don't have to, but it is kind of important to understand that, this is guns we're talking about here, number of guns per household. So that's always a nice thing to do. Now, keep in mind, conceptually then, if the person did the study that we just invented down here, notice they decided they wanted to be really confident. 98% is a pretty high confidence level. And they did check with 172 people, which is a fairly decent sized study, at least by our standards in this classroom. And so then they got all this information. And so this is the result. Now remember, what does this mean? This means that although the study came up with a sample mean of 3.3, the actual mean, the population mean, could be as low as 2. Because we came up with an error of, what is it, 1.3? That's what you got for your error, is 1.3 guns. So we are 98% confident that the actual answer to this question, how many guns are in a household, is between 2 and 4.6. Remember, that means, and I'm going to say this for the sake of the section we're studying right now, the alpha, the leftover, this also means, does it make sense that there's a 2% chance we got it wrong? So 2% chance. And you will see this word in the chapter 10 section, but basically what's going to happen in chapter 10 is instead of focusing at 98% chance correct, we're actually going to focus on what percent error is there. We're going to focus on the 0.02. The questions in chapter 9, they always gave you 98%, but the questions in 10.2, they're going to give you 2%. It's the same thing, it's the same information. But what makes this section hard is if you see it as a brand new section, it is hard. It's like a brand new problem, and we've already done quite a few things, and my brain is spinning a little bit, you should think. But all they're going to do in this section is just give you the error. So there's a 2% chance we're wrong. Now, does it make sense if you went and did your own study, you did, because you disagreed, and you thought the mean was actually higher than 3.3? Maybe because of the folks you roll with, everybody has guns, and so you're like, that's not true, that's too low, I don't think that's right, or at least not right anymore. And so you did your study, and you got that the sample mean was, say, 5.2 or something like that. Now, if the established wisdom was 3.3, you did your study and got 5.2, does it make sense you feel good about that? Because you thought it was bigger, you went and did a study, and you were right. Now, the problem is, who's right here? This was a study, and this was a study. So who's right? I mean, just because you got a bigger answer, does that mean you're right? Well, what we did in the past here, this confidence level, this confidence interval, is kind of the key to this. Here's the conceptual understanding part of this. You were intellectually honest enough to say that although I got an average of 3.3, the actual answer could be anywhere in here. And so if you did your study and got 4.1, does it make sense that actually falls in this range up here? Like, we knew this was wrong anyway, right? We did a study, but we knew it could be off. And based on our confidence interval, the fact that we said a 2% error is acceptable, we said this is where the real sample or the population mean could be, and this number actually fell inside that. If this is what happened with your study, you would basically say there's not enough evidence. Evidence for what? Well, to believe you thought it was higher, 3.3, and your initial reaction was, see, I got 4.1, it's higher. But based on this range back here, is it high enough to say this was wrong? Remember, this study is great. You got 3.3, but with the error involved, there's a little bit of room for wiggle. And so your 4.1 fell in that range right there. There's actually not enough evidence to overturn it. That doesn't mean it isn't true. Like it could actually be that it has risen a little bit, but you don't have enough evidence because there's actually a range of answers up here. It's not just the number that you got. However, if you did this study, and as I said a minute ago, got something like 5.2, now there is evidence. Again, evidence for what? Well, that mu is actually bigger than 3.3. There was not enough evidence that the population average was more than 3.3, but you see how logically the 5.2 is outside of this range? And remember, there's 98% of studies that are going to fall inside this range. If somebody repeats it, it means 98% of the studies that are done are going to fall inside this range. The interesting part of this, and this is what's kind of cool about statistics and also kind of awful, is you actually can't know anything here. Ultimately, you can't prove it because you'd have to check with every single household. And that's what statistics is about. It's making educated guesses off limited information. I can't check with every household. That is just way too time consuming and expensive. Not only that, by the time I get to the last person, the first few people bought more guns or sold their guns, and it's not even right even then. But the concept here is that there's still a 2% chance you're wrong. So conceptually, we're not doing anything different in this section. We're just using the concept of a confidence interval. Now we're going to approach it a little differently. But there's a part of me that says this is the way it should be taught. If I was writing the book, and especially for people that are, you know, this is your last math class and you really don't even need to know this section, I'd be very tempted to not make this near as formal and weird as I kind of have to make it, because you would not be able to answer the questions in the book. But all I'm saying is, if you conceptually, if you did a confidence interval, got this range, and then you did your study and your study fell inside that range, then you'd have to say there's not enough evidence to overturn it. There's not enough evidence that the mean is actually bigger like I thought it was. It looks like it is. It's not saying it might not indeed be, but there's not enough evidence to overturn it because your number fell inside that range. If your number is even bigger than that, then there is evidence. Now, remember, there's still a 2% chance you're wrong. If you got 5.2 and you said, yep, indeed it's higher. Notice you're not actually saying you know what it is. You're not saying it is now 5.2, because your study would also have a range, right? It's not like 5.2 is the right answer. Your study would have a range just like this one did. And so it might go all the way down to 4 and all the way up to 6 or something. It has a range as well. So you're not able to say this is the new answer now, but you're at least able to say, because your answer fell outside of this, that it's higher than it was. But there's still a 2% chance you're wrong. You see how, like, this is sort of frustrating, that you can't know. Unless you check with every house, you can't know. Now, this is just a question of interest, but what if you're talking about somebody going to the electric chair, like the death penalty? And so you're doing some kind of a, you know, CSI kind of a study based on whatever, some blood that was at the crime scene. And so you're trying to put them at the crime scene, that kind of a thing. And you end up not being able to know for sure, because the blood that was at the scene has, and I actually don't know enough about biology to even know if this, what I'm saying is even true here, but let's say that, you know, the blood that the person you thought did it was similar to the blood that was at the scene. In other words, it had some of the same markers, but there are other blood types that do too. Does it make sense? Now you're under the situation of kind of saying, well, as the prosecuting attorney, you know, does this person go to the death chair? It's kind of like, well, if there's a 98% chance they did it, Should you send them to the death chair? You have evidence. You have evidence that there's only a 2% chance that wasn't the person. And so, sorry, you're going to have to go to the electric chair. Or, are you more minded like, well, gee, if there's a 2% chance they didn't do it and you kill them, that seems like a worse mistake to make. But see, that's kind of what happens. That's what happens in the real world. You have to make decisions based on kind of an educated guess, but you won't be sure. Even something as simple as how many pairs of shoes should I order of different sizes? I run the shoe store, the shoe department. How many should I run of each size? You have to guess at that because you don't know exactly the spread of different shoe sizes in the population, and you don't know who's going to walk in your store. You're going to get it wrong. But at least if you make an educated guess based on math, at least you have a shot at being right instead of just making it up from scratch. I mean, that's the idea behind hypothesis testing. It's basically looking at data, and then you disagree and think, no, it's higher, no, it's lower. And then you'd go do your own study and then kind of see, is there evidence to say that, yeah, in fact, it is lower. Okay, that's the concept behind hypothesis testing. So it conceptually really isn't different than what you already did. But let's talk about 10.1 is actually specifically talking kind of about the language. I'll just say hypothesis testing. And the assignment for this is short. All the assignment in all these sections is actually pretty short. And it's not terribly hard. That's the math teacher talking, but let's get into this. So one, as I said a second ago, you're not going to be told 98% anymore. You're going to be told instead the alpha. It's the same alpha we've been talking about, but you're going to be given the 2%. And as I said a second ago, that's the significance level. And this represents kind of the chance that you're wrong. If I'm ordering shoes, then I probably would pick a number like 6%. I don't mind if I'm a little wrong. If I'm going to send someone to a death penalty, I'm probably going to say something like 2% or 1%. Or the cables that we worked on yesterday that were breaking. Like, I can't really afford to be wrong with something that people's life depends on. So I'm going to choose a really small significance level. So this is the percent chance that you're wrong, basically. And in the real world, you get to pick what that is. But of course, in your assignment, they're just going to tell you, do this at a 3% significance level. Just understand that that means, oh, okay, I'm willing to accept that there's a 3% chance that I'm wrong about this. That seems reasonable to me. So do you see that it's the other side of what you already know conceptually? Secondly, there is a thing called what your book will call, and again, there's a whole chapter devoted to language because this is kind of a pain, the null hypothesis. What is this? This is the previously established I guess I'll just say number for now. In other words, a second ago, we looked up on the internet and we saw on the internet that somebody said it was 3.3 guns. Notice I used the population answer for this. That's the established wisdom that I found from the internet, from some study that somebody did. That's the established wisdom. And so what you will see then is this. So I'll write it this way. That little H with a 0 on it. That little 0 down there is a common thing for all kinds of sciences. You may have never ran across this in a class yet, but that's the initial hypothesis. So null really kind of means initial. the previous established number. This is the initial, this is the established fact. So in a physics class, it might look something like this. Your speed, I'll erase this, but your speed, your initial speed, like when you were driving the car, your initial speed was 75 miles an hour. And then your speed 1 second later went down 3, and so now you're at 72. And then your speed 2 seconds later went back up to 76. So this is why that language gets used in like physics and other classes. So S of 0 is always your initial speed. That's what happened when you started. And then as time went on, it changed to something else. So this is always for things that are changing. So this is used other places, I guess. So null hypothesis is the established fact. And then a second ago, we came in and said we didn't think that was true. We came up with well, the next one. Does that make sense? So it's almost like time 0 and time 1. We came up with a different hypothesis, and we said we thought that that was wrong and that it was actually higher than that. Now, again, you're pulling that out of the air. And that's why, again, I took the time to ask all of you the question. Do you think it's about right? Do you think it's higher? Do you think it's lower? You pull that out of the air. But based on your experience, you said, no, I actually think it's higher. Now, keep in mind, you haven't done a study yet, so you don't know. For all you know, although you thought it was higher, it's actually lower. This is what your book will call the alternate. At least that's a word that makes sense. Null probably is not a word you use much. This is the alternate hypothesis. So your assignment in 10.1 is just going to ask a bunch of questions about this. And we'll practice this a little bit, but it'll just give you a problem and explanation. And it'll ask you, what's the null hypothesis? Excuse me. What's the null hypothesis and what's the alternate hypothesis? So these are important words, I guess is what I'm getting at. These are words that you will not even be able to read the question and even understand what it's asking unless you have this language down. Lastly, in the confidence interval thing, does it make sense? We always took that error of 2% back here. We knew that 98% was in the middle. And so we took that error of 2% and we always cut it in half. That's why there was that little alpha over 2 symbol next to Z. We always cut that in half. But here, does it make sense that this person said they thought it was actually greater? If that's the case, then we're basically putting all, let's see, I think I'll draw this over here. They're putting all 98% over here and all 2% up here because you think it's greater. You're putting all the air up there. You're not splitting it up. So the last consideration is where does that error, that's error is not the right word. Where does that alpha, that significance level, that percent, where does that go? In this case, because that was greater, the language that you'll see, and you'll be asked this in your assignment, is this is right-tailed. So if it's greater, it'll be right-tailed, meaning all 2% goes there. You don't split it in half.
So if you're testing a hypothesis that you have to decide if you think it's less, or if it's lower or higher than.
That's an excellent question. Do you understand what she just asked? She said, do you have to make a guess? In other words, Well, like a lot of you said, no, I think it probably is 3.3. That sounds about right to me. But let's say you just were curious if it actually was. And so you went into your study just saying, I don't know, it could be bigger or smaller, or maybe it's actually right on. So actually, I'm not sure. I'm not going to pick, which by the way, is kind of what people do scientifically. Like if I say it's greater, that's just because of my feelings, right? And maybe that's not such a good way to do science. I feel that it's higher. And so you just go into it saying, I don't know. No, there actually is a two-tailed test where you do what we always did, which is split it up and put 1% on each side and 1% on the other. So that's up to you. And that'll be part of the questions you have to answer in tonight's assignment. They'll say, suppose you think instead of, and we'll do examples of this, but instead of you saying, no, I think it's bigger, you can just say, you don't agree. Like you might see in the question, they don't agree with this. They don't think that's right. But notice they didn't commit to greater than or less than. If that's the case, then it won't be right-tailed. It'll be two-tailed, meaning you got to put the percent in both tails, just like we've been doing in the past section. So no, you don't have to commit. Let's do some more examples. So all I want to do is just try to, help these three, well, I guess these four, significance level, you'll be told that. And then this business is, which tail is it? I just want that to go into you as, as deeply as it can. Let's see. So I looked up a whole bunch of kind of really cool or, data that you might be surprised by. So, or at least have an opinion about. Here's one. 11% of people have never left their home state. Saw that on the internet. I won't go around the room this time, but does that seem high? Does that seem low? Does that seem about right to you? Never left. Never even been there. Never even drove to California. We live really close to the California border. However, if you cross the California border, there's still nothing. But it'd be like if I lived in Eugene, right in the middle of the state, you'd have to drive further to kind of get out of the state. And you don't do it just to do it. Say you've been to another state, it kind of needs to be something there that you want to see, like people or something. Anyway, saw it on the internet, whatever. My gut reaction is that's high. I just can't believe that that's true. However, I did go visit my high school friend in Ohio. I told you, I think a couple of weekends ago, just because he's having some trouble. And after being there, that I understood that statistic more. Here, there's just a lot of cool, like oceans and the California coast, you can swim. And so there's kind of a lot of neat stuff in the surrounding states. But in Ohio, if you go to the next state over, same exact thing, man, there's nothing there. However, Niagara Falls was kind of close to where he is, and you got to cross into Pennsylvania to go see it. It's a driving distance. And so it's kind of hard to imagine that somebody in Ohio has never driven over to Niagara Falls for the day and driven home. But that's what this is talking about. 11% of people never even crossed the border ever. Not talking about moving, never even left it. So my gut reaction is, I can't believe it's that high. So this is the established wisdom. Do you understand that? And again, who established this? How did they do it? There's a lot of questions there. But what do I call that? Does it make sense in the last section? I called the established wisdom. Well, what did I call it? I called it mu because the question at hand was a number. It was a mean. The average number of guns is 3.3. That's the established wisdom. What do I call this though? Because of the kind of data it is. A what? Notice it's a percentage. So you don't say the mean is 11%. That's not what a mean is. What did we call that? Yeah, p hat. except for it's not really p hat, it's p. P hat would be if you did a study. I found this on the internet. That is p, the population proportion. That's the established fact. Now, again, the internet established that in my case. So that's pretty suspect. But if somebody actually did a study, and especially if they checked with 9,000 people or something, really did a good job of it, that would be the established fact. Again, I find this a little confusing because in order to say P, you're acting like you checked with everybody. Does that make sense? If they did a study, really that's not P, it's P hat. They did a study, and so that's their best guess. But basically, we're calling it P because that represents the established wisdom on this. That's the established fact. It's 11%. Then you come along and you say, I have an alternate. I disagree with this. You have an alternate hypothesis. You don't think that's true. But let's kind of go with, now in my case, as I said a second ago, well, let's go with what I said. I said my initial thought was that that's too high. So how do I state that? How do I state? I say, no, I think that P is actually less than 11%. So what I want to add to this is just the language I said before. Does it make sense? That's the way you say null hypothesis. Again, mathematicians love symbols. They don't want to write the word null hypothesis out every single time. So instead of that, they write this, that symbol. Initial hypothesis is that P is 11%. You come along and say, no, I have a second one. I have that might have been the case at time 0, but now that it's time 1, I think that's not true anymore. Remember, this doesn't mean the study was wrong or that person was an idiot. It could mean just that time has passed and now people travel more than they used to. And so I think it's more. In my case, I'm saying I think it's wrong because I think it's less. So I've stated the null hypothesis. I've stated the alternate hypothesis. And because of this, what type of test is this? And your choices are either left, right, or two-tailed. In other words, where does this error go? Because I committed to, I think it's less, then that means I'm putting all of my error on the left side of this. So that makes it left-tailed in this case. And as we wade into the next chapters, you'll see what we do with this or why it's important to know that. But it's entirely based off of you committed to saying, I think it's less. Now, of course, if you do a study and get 13%, that's going to kind of make you, I don't know if an idiot's the right word, but it's kind of like you thought it was less, you went to all the trouble to do it, and it was actually more. Which is why scientists typically don't commit to left or right. They just say, well, I think it's left, but I'm not really sure. I just think it's wrong. And then it'd be two-tailed. That's actually all you need for tonight's assignment right there. You'll be given a statement up here at the top like this, and then they'll say, state the null hypothesis, state the alternate hypothesis, and is this left, right, or two-tailed test? And you'll just kind of click on all that. Did you say as a percent?
When it's two-tailed.
Yeah, let's do an example like that. So here's a second question.
What do we write in the homework?
Well, the homework is going to be like, it's going to say, is it kind of like I did here? It's going to say, is it left, right, or two-tailed? And then you'll either click on one of them or write one of them. And we'll probably look at the assignment here just because this is kind of confusing looking, just to kind of make sure you feel good about it. Second question. Again, I'm just looking at other interesting things I found here. Oh, here's a cool one. Teens send 60 texts per day. Also hunted that up yesterday. I won't go around the room, but form your opinion. Do you think that's low? Do you think that's high? Anybody want to say what they think? You think it's low? It's a lot of text.
I mean, it's a lot of text for like me, so I figured that's probably fine for.
Yeah, and of course
I
it's
go to school and stuff.
it's kind of, I mean, kids are sitting in class and somebody's trying to teach them statistics. It's like, I'm gonna text my girlfriend or whatever rather than listen to this. It would make sense that teens are higher than adults. Now, the other thing that's interesting about this one is that has definitely changed over the last 10 years, right? Because it's kind of gotten easier. There's all kinds of cool things on your phone. You can, silence it and so forth. So you can just fill the text in your pocket. You can pull it out. The teacher can't see. I'm thinking of high school kids since we're talking about teenagers. So you can kind of pull this off subversively. And also, like, even in a class like this, like, it's not an interruption. If you're paying attention, but if your phone buzzes, you probably take a quick look at it, don't you? Just to make sure it's not super important. And if it's like a three-word reply, like, you probably responded. And I actually think that's fine. You have to be mature enough to, if it's like a 10-minute text, then you're probably gonna miss something, and that'd be stupid. But anyway, awesome. But the point is, this probably has changed over time. So if you disagree with this, it could be just because that actually is true, but that was in 2019 that was done, and now it's 2022, and so I think it's changed. So what would have to be included with this question? I'll add a little bit more detail. So that's the established fact, and you disagree. Notice we have not committed, like we did up here, to you think less. I said that in words, but does it make sense that would have to be included in the question for you to decide if it's left, right, or two-tailed? You just disagree with this, and so you're going to go do your own study and kind of see if you have evidence that it's not true. Now, of course, if you do your study and get 61 texts, it's probably going to be like, well, I guess that's probably 60 is probably reasonable. But if you get 80, then that might be argument to say, yeah, it actually is increasing. So could you state all of these? And I won't write the whole thing out, but can you state the null hypothesis? Can you state the alternate hypothesis? And then where does all of your error go in this problem? That's the 3 questions you'll be asked. I'll just give you a second to either think about it or maybe even scratch something down on your paper.
When you write out the first things, you need to put like would it be 60 or would it be 60 texts per day, or like how would you want that?
Yeah, and in most of the questions in your assignment, this is all going to be pull down menu stuff. Like, you're not typing anything, because notice we have weird symbols like p-hat. You can't type p-hat on your screen, or that little mu symbol that meant population mean. You don't have that symbol on your keyboard, so it'll be like drag. You'll click on it and drag down to whichever one you think it is.
Like, for instance, would you want to state it as like the whole thing, or just like numbers?
Basically numbers. This is what your answer will look like in my open math. The null hypothesis is H0 every single time. The alternate hypothesis is H1 every single time. And I can't remember if you picked that or if that's already there. I think that might already be there. And then you drag down what you actually say. But just like in the last section, does it make sense last time our data was a %? So that's the big consideration. Did this person want to know a percentage? And I think you would agree, there are interesting questions that fall into those 2 categories. If you're curious about how many people have left the state, a % is really the only data that would even make sense there. But if we're talking about text being sent in a day, a percentage is not the natural question. But the key here is to recognize, hey, this is not a percent, this is a mean. And so your hypothesis, your established hypothesis would be that mu, and you're gonna have to pick that. Last time it was P because it was a percentage. This time it's mu. So like that's what you're gonna be entering. You disagreed. You notice in the problem there, it didn't say you think it's lower, you think it's higher.
Could you pick one?
No, you say, and we haven't done this yet, you say, don't pick one. You say, no, it's not that. That's how you say it. You say it's not equal to that. That'll be one of the things you drop down because again, you can't type that symbol. You say, I don't think it is. So you don't commit to greater or less than, use a totally different sign. I think it's not 60. But you haven't committed to where the error goes. Therefore, this is two-tailed. See the logic in that? Yeah, so in this case, I'll just, this won't be part of your assignment tonight, but it will be in 10.2 and 10.3. So let's say this question, well, doesn't this feel like number of texts per day? Like this is just a question of interest. However, you could say people staring at their cell phones all day long has got some deleterious or negative effects on people. And so maybe this is really serious to you. Maybe this is your entire life's work is to study the effects of this. And maybe you're going to try to, change something in policy of the country to kind of limit that or something. You're afraid it's really causing some problems, which I think there might be some merit to. So you say, I'm going to go do my own study at a 4% level of significance. In other words, I'm going to go do a study and I'm okay with it. I'm okay with there being a 4% chance I'm wrong, meaning automatically there's a 96% chance I'm right. And so this is two-tailed because just like we've been doing lately, you're saying, I don't know where that 96% is, but because I haven't committed to it being high or low, then that means I'm going to have to split that 4% into half, just like we've been doing recently. So again, that'll make like mathematically as we start kind of doing confidence interval, like kind of like we did at the start of class, mathematically, basically, I'm going to be working with 2% instead of 4%. That's kind of the idea. So the reason they ask you for the language of is this left-tailed or right-tailed or two-tailed is it has to do with what do you do with that error. This last problem, because we said it was left-tailed, if it was the same exact problem, then we would have said all 4% is over here in the left tail. And so we'll be doing our math with 4% in this problem, whereas we'll be doing it with 2% in this problem. And that'll change the z-score that we get because we'll be using 4 instead of 2. So that's why it's important to kind of say, I haven't committed to whether this is wrong high or wrong low. I just think it's changed. So it isn't even so much that you even have to say that you disagree. You could just say you think it changed. Because that study came out in 2019 and that's 3 years later or something like that. But you just don't, you're not sure. Maybe it went down. Let's just do one more and then we'll maybe take a quick look at my open math and then you can finish your assignment if you want to. Let's see, another interesting one. Let's switch to a percent. Here's this is the third question. 16% of Americans don't know their neighbors' names. Now, again, I found that yesterday, just looking around. And of course, like, what does it mean to know your neighbor? This person said their name. Like, if you know their name, then we'll say you know them. It's kind of hard to, what does it mean to know your neighbor? If you say, if the study said they don't know their neighbors, what is it, how long, how much conversation do you have to have before you can say you know somebody? That'd be really hard to define. And then, of course, this is complicated because at my house, I have like 4 or 5 neighbors. I know some of their names, but I don't know all of them. So how am I supposed to answer this question? Somebody came up to me with a clipboard and said, do you know your neighbors' names? I'd have to go, well, it depends on what you mean. I know one of them. I know 2 of them. I'm not sure about that guy. Again, you might think that's the established wisdom, but I'm not sure. You think it's actually higher than that. And maybe that's because you don't know your neighbors' names and they don't know your names, and I don't, people just don't, your friends are across town. We have cell phones now. So it's easy to have friends. You're not really have to rely on people that are right next to you. So nobody knows their neighbors' names. I actually think that's high. I think it's less than that. Can you do the same 3 things? Can you state? And I would like you to scratch this one down at least. What's the null hypothesis? What's the alternate hypothesis? And how many tails? Or I guess I should leave it the way I said before, tailed. How is this test tailed? Again, a little yeah, notice it's a percent. So you got to think about what are you going to call this? And you'll have, and I'll show you in a second, when you look at the pull down menu, there's going to be like 8 options for what you should put there. So Ken is exactly right, because the data here is a percentage. So because it's a percentage, you would say P, not mu, is equal to 16%. Of course, you can write 16% like this, or you could write 16% as 0.16. My open math might be asking for one of those 2. So again, you got to kind of pay attention to that. You said higher, that's the key word here. So then you come back and say, and as I said before, you know, maybe saying H0 there is fine. So you say, no, I actually think P is higher than that. So you're disagreeing with that. Because you committed to higher, what kind of a tailed test is this? Right, higher. All of whatever error there is you find acceptable in your test, I'm fine with a 6% error. You might say, this isn't that important. This isn't a life-changing thing. 6% chance I'm wrong, that's fine. No one's going to need the electric chair. You committed to all of it being in the right side. Okay, let's just take a quick look at the assignment. See if you recognize the flavor of these questions. So I need to share a different screen for those people at home. Man, these controls are always in the way. So last assignments, 10.1, 2, and 3. Let's look at 10.1. Let's just skip to one of the questions down at the bottom. I don't know, this one. So just read question 5. Your question 5 is going to read exactly like this. The words won't change, but what might change is that 35% or something like that. Notice it says past studies have indicated that the percentage of smokers is estimated to be about 35%. There's the established wisdom. Again, I'd like you to write this on scratch paper really quick because I'm probably going to go ahead and answer this on here just so you can see the flavor of the way the question is worded. Given the new smoking cessation program, notice this is kind of cool because this isn't just somebody's opinion. This is somebody saying, all right, I'm going to come up with a program to help people quit smoking. And then you implement that for 2 years. And now you're curious, did it actually make a difference? Is it lower than 35% now? In other words, did your program work? This is not just nerds disagreeing with each other. This is you did something to change something. And now you're asking, did it work? So you now believe the percentage of smokers has reduced. You got the government to give you $1 million to run your Just Say No to Drugs campaign or something like that. And now you spent it, and now you're going to go do a study to see if it actually worked. Did it actually reduce that percent? Yeah, go ahead. Say it again. This is 10.1. If you going to test this claim, I'm glad I didn't write that statement. If you going to test this claim at the 0.05 significance level, what would be your null and alternate hypothesis? So do you see what I'm saying? If you didn't know those two words, it'd be like, what the heck is this talking about? H0, H1. Notice it's a pull down menu. H0. Whoa, look at all those options, man. Wow, there's like 20 of them there. Woo. Which one do I pick? Your data is a percentage, so you should be looking at P, not mu. And look at all the choices I have. Less than, greater than, less than or equal to, greater than or equal to. Woo! There's a lot of them there. Which one is it? Somebody blurt it out. It's equal to here because that is the established percent. In other words, you believe that that is equal to. Notice I pulled that menu down, but here I got to type it. I don't see a percent sign, so I think I can type 0.35. I'm not sure. We'll see in a second. I wonder if I could type 35 with a percent sign behind it. I don't know. The established wisdom is that P is 35%, but you come along and say, no, I think it has reduced. So the key word here is it reduced. It's less. So you think P is less. Well, how do I know it's less and not less than or equal to? I think, if I remember right, that's an irrelevant distinction. Like it actually doesn't care, which I'm glad for. I actually don't think it matters. As long as you say less because of the word reduced, you're fine. Less than what? Well, less than 35%. Is that what we've been doing? Now, because it's less than, is it left, right, or two-tailed? Left-tailed. Let's see if I got these right. Kind of surprised by that. I was hoping that that was the case, but notice it actually didn't like the less than or equal to. It indeed wanted less than. I suppose that's because in the way this is worded, it didn't say, it said reduced. It didn't say equal to or reduced. So maybe that is a distinction. Again, I'm a little disappointed with that. I wish they didn't even have that option. I wish it was equal, not equal, less than, greater than, and don't have these last two, because that's kind of splitting hairs. But again, you get 3 tries with this, so if there's some little weird like that, great. So isn't that what we just talked about? It looks a little weird here because you're doing pull down menus, and that's why I took the time to show you this question. I think that kind of makes sense. What are the first questions asking? You'd assume they're maybe a little easier. Do you notice there's no words associated with this? They just say, and so we don't even know what this is talking about. They say P is equal to 0.21. Alternate hypothesis, P is less than 0.21. And just based on that alone, you should be able to say what the tail is, even without all the wording, because they sort of omitted the wording and just wrote down the mathematical symbols for it. There are a whopping 6 questions here. I actually removed the 7th question. There's a whopping 6 questions here. If you want to, you could do them all right now. But I will shut up and you can ask me, since you turned in your hand-in homework yesterday, I hope, the only thing you owe me still is the lab. So you could ask me a lab question if you want to. I can check that to see if you're right. You can work on this homework, or you can say, I just want out of here, man, I'm gone. But I will give the rest of the time to you. Do with as you please.